I'll kick this off with a pretty high-level overview. That first sentence, our purpose of boil water treatment is to minimize corrosion throughout the steam cycle, including steam, feed, condensate, and the boilers themselves. It sounds pretty simplistic, but the way we treat boilers is a little bit different than how we treat cooling towers or closed loop or other chemical systems. Is we really don't add true corrosion inhibitors to the boiler system. Really, we remove aggressive and fouling ions like calcium, magnesium, and chlorides and sulfates and silicas. And then we reduce and remove oxygen via mechanical and chemical means. And we raise pH, and we really rely on the natural passivation at this higher pH and higher temperatures to do the corrosion inhibition. And actually, the only really true corrosion inhibitors that we add to the steam cycle in some cases could be a film forming amine. We don't discuss it much today, but we do see film forming amine use very prevalent in the power industry, and it's growing in our industries, in the chemical, petrochem, and refining industries as well. And then the oxygen scavengers themselves, some of the organic oxygen scavengers do have some slight passivation properties. But again, really the work is done up front, and we'll discuss that in more detail. The second purpose is to minimize deposition. Now, this is also done during pre-treatment, but the deposition that we're mostly concerned with, and we're going to discuss a lot today, is iron and sometimes copper transport into our steam generators and boilers. All the iron or the majority of iron that transports into these boilers will deposit, unfortunately, in higher heat flux areas preferentially, and that causes sites for under-deposit corrosion, so we'll discuss that in more detail. One of the other gaps that we see is in our industry compared to a lot of other industries is our ability to monitor steam quality and maintain that sodium and silica and free of chlorides and sulfates. All these constituents and ions can foul the turbine blades and cause corrosion in the form of stress corrosion cracking that we normally would see at the wet ends of the turbine blades. We'll discuss that in a little bit more detail.